Why not
Okay.
assign today's day to dealing with the pointers and deal
Yeah.
with the projects yesterday? So, and that's what we agreed on. But when I look at things, I realize that, yeah, of course, there were a lot of concepts that we needed to understand on those projects.
Mm.
But at the end of the day, we ended up doing only two. We dealt with only two projects because we spend
Okay.
a lot of time uh, explaining concepts, which is good anyway, which is still a good thing because some of the concepts are very difficult to understand. So
Okay.
I'm just suggesting that maybe in your plan, in your schedule of what we are going to do with pointers, all the concepts
Okay.
that we you are trying to explain, maybe we can have. I don't know if we can maybe ask somebody to just set the time for us to say, okay, now this concept we are going to take 20 minutes or 30 minutes. We explain it, then we move to the next concept, so that because I realize we take like 3 hours on the or 2 hours or so, and we might just realize that we did only a few concepts. Anyway, your explanations really are good and you really kill it. But then even when it's dead already, you continue killing it more, and which is good in many ways, so we all understand. But I'm
Okay.
just so I don't know. I'm just saying, can we try to strategize our time? Maybe have some fractions to say, from this time to this time we deal with the concept, then we move to the next one. Then, so by the time we are done with those 3 hours, maybe if we have four concepts done or five concepts done. I'm not sure if I'm clear on this one. It was just any suggestion anyway.
Okay. I can get your point. Okay. Actually, this one would not be the plan I have for today. I understand that sometimes going back and trying to review some concepts based on looking at majority, some things are not clear. We try to break down. At some point, we use more time than usual. Although it's still
Yeah,
good, but we the time is not always on our side, and we just need to maximize and use the time as best as we can to quickly just make use of get the best thing that we can get. So what I'm trying
yeah.
to do, what I'm going to do today, the plan is that today is going to be on pointers, solely on pointers. And
Okay,
yes, if there is any clarification or probably regarding some concepts anybody is having issue with, the person should have it within his or him or herself, and it will be like a question at the end of this pointer um, lecture or this pointer session. The pointer session will be around at most 45 minutes if I'm able to capture
okay,
every detail. Yes. So after
okay,
that, we'll then have room for probably reviewing the question on the pointer itself and then question on probably any other concept. Then we'll see that today's lecture will at least, at most, we should round off by 1 hour 30 minutes. That's what we should use. That's the plan.
all right, all
one
right.
hour 30 minutes. Yes. Okay. So Abisola, you be my timekeeper for today. So we are gonna start with
Noted.
pointers. So okay. So all right, guys. Now I'll assume everybody, of course, we already understand the basics. Understand get the basic structure of the C programming or C program, and then at least we can use if else statement, we can use the printf, the put char, even the puts function, and we can create variables. Okay, this is even where it's necessary. We can create variables and we understand data types. So now pointers in C. Okay, now look at with what I have here. One thing that you need to what put in your mind and in your understanding or try to understand, I have been able to put them into how many points? 5 points. As based on when based on the way I try to see things, if you are trying to learn something, there are a lot of things that will be said, but among all those amount or many lot of things that has been said, it will be that probably there are some key points in the numerous information that you have gathered. So I have been able to what outline the key points that you need to what put within yourself as the necessary things you need to know about pointers. Okay, so first thing you need to know is that pointer or pointers, it all talks about memory address. So when you hear pointers, you should all your what should come to your mind is about memory addresses. Okay, so now point one, it is important to understand that programs and data, that is variables that are what stored in the computer's memory while executing. Okay, that is okay. Sorry, what does this point one means? That is every program and data or variables that are stored, every programs or data that is variables in the computer, they are stored in the computer's memory. Sorry, there's a typo here actually. So that is our first point, that programs or variables, they are all stored in the computer memory. They have a location in the computer memory. Now, point two means for every variable that is created, a unique address is assigned to that variable. Okay, so I would say you should take it from point two. I think point one is a bit confused. So what you should know now is that for variables that are created, a unique address is assigned to that variable. Okay, now address are like what? Some unique values allocated or given to every variable in order to distinctively or uniquely differentiate them from other variables. Imagine we can have up to like, probably you're creating a program that will a program to calculate the average of five numbers. And what? You created variables for those five numbers, right? Okay. So let's say all the variables are integer variables, the data type, and you created them. Okay. And one thing you need to understand is that for the first variable to the last variable that you created, there is what? A unique address assigned, given to that variable. That is one point that you need to you need to understand. So all that we are trying to say is that for all the variables that you use while you are writing a program, you should know that they have a unique address assigned to them in the computer memory. There's a unique location. Okay, that's point three. Now, point four, to recap again, for all variables created, they all have a location or position or address in the computer memory. Trying to emphasize on this, that this variable A, it has an address. This variable B, it has a specific address. That point is very, very necessary. Now, the last point that you need to know is that variables are just containers, identifiers, or anything we can call by name. Okay? So that as it is, variables are just containers to hold value. Okay? So for every container that you create or variable that you create, you actually give it a name. But there is a big understanding that you need to take on with you, that it has a location in the computer memory. So that address or that location in the computer memory is what makes a variable different from another variable. And there is a reason for that, because imagine where you create about 1,000 of different variable to do different things, and you want to what? Actually do some manipulation to those variables. Aside the fact that you have the name of the variable in order for you to be able to do that, there is another thing behind the scene that is needed in order to do even advanced or more complex tasks with variables. And that has to do with what? The unique ID, okay, given to that variable. You can call it like a unique ID. And that unique ID we are talking about is nothing but what? The address of that variable. So on a normal day, what you need to understand is that every variable that you see that they have a value assigned to them, the truth behind everything is that the actual value, that value that you see given to variable, probably you see int a equals 30. it is not actually A that is holding that 30. That name A is just like the container that we put 30 inside. The value, the actual value 30 is actually stored in the address given to that variable. So it is just like you now, for you, between you and I, if you tell me your address, or if I tell you my address or my location where I am, if I tell you my address, my address will have probably number something 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 street. It is when what you use that address, when you follow up with that my address, that is when you can find me, which is my actual self. So that is just the concept that variables, they have a location in the computer memory. Okay, so variables are just containers, identifier, or anything that we can call by name. Yes, it is a container because we can use it to store different types of data. It has an address, and it is in this address its value is stored. Look at this. Yes, it must have an address because the computer, the memory must keep track. It must keep track record of all that is happening to the variable. So it is by the address. Now, somebody is raising up hand. Yes, please come in. Quickly.
Okay, yes, everyone. I think I need something clarified before we go further, before I get lost. Okay, so you are saying
Okay.
uh, variable, when we say maybe int a, that a is just the container.
Yes,
So if I say a equals to
exactly.
30, then that
Yes.
30 is the value. So I want to know, is this a the address itself, or, because to me it's like the a itself is pointing to 30, or there is some other address that points to that 30.
Okay. 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 So if I get your question very well, you're trying to look at, is it that it is that A that is the address, or there is something behind the scene? And yes, there is something behind the scene. The A is just the container, just like you said, and just like what we are trying to explain. The A is just the identifier, that is just to tell that this value, this, let's say I say int A equals 30. So what we are trying to say is that because we need to use the value 30, we are what? Assigning it to a container, or putting it inside this container 30, A, with the name 30. Okay. So what, there is something unique about this A that was created, and that uniqueness is that as it is that we create this A, it has a location in the memory already. It's as if like it has been registered in memory and given a unique identity, such that if there's a way we can what, capture and or gain access to this A, this very A, and then get into the value it is storing itself, and then do some manipulation to it. So one thing you just need to understand is that all this A, this name that you can see probably int A, int my number, even without giving it a value, or char my name, and my name, or it is like that, they are just what, containers for that are needed for us to use. Okay, is that clear? Somebody is raising up hand again. Hello, Ramatamo, is that clear? Who is raising up hand? Please
Okay.
come in.
Sorry, Mike. Thank you. It's very clear now. It's clear.
Okay,
Yeah,
somebody.
it's me. It's me.
Okay,
So I just wanted to ask if this video is being recorded because I'm kind of having network issues here.
yes, it is, it is. Okay, another person, please
Okay,
quickly.
that means I can.
Okay, yes,
Okay,
you can, we'll share the link, it's being recorded.
okay, okay.
Yes. Okay, next person. Nobody.
Nobody. I think it's Ola that kept raising his hand.
Okay. So just understand the variable names are containers, okay, and they have a special location in the memory. Now look at this chart here. Let me maximize this. Now look at what we have here. We have this variable, and the name of this variable with its type, it has a type of int, an integer, and with the name x. Now it is saying that this variable x, it have an address or location, and the address is something like this: 0x032, excuse me, 0x0325 FBC. And you can see that this arrow is pointing down, saying that the value at the address is 60. This is behind the scene. On a normal day, this is what we will see: int x equals 60. But breaking it down, we see that the actual variable name is int x, okay? But it has an address in the computer memory, it has been registered, and it has the value 60. Now, there's a note here. It says memory addresses are positive integers, okay, that uniquely identifies or tells us a position of that variable in memory. All that we have been saying so far is that if you should create a variable that you want to use, know that those variables, they have a unique location, they have a unique address in the computer memory. And why is this so? We will understand soon when we get deeper with pointers. So all that we have said so far, every variable that has been created, they have a position or location or an address in the computer memory. Now, going forth, now what are pointers? This is what you need to know about pointers. Pointers are special variables whose job is to store or hold the address of another variable. Now, let me break this down before I go into pointers. Now, we've been shouting and we've been saying that every variable created, they have a location in the computer memory. How true is this? Did you remember this operator, the ampersand operator? Did you remember that we can use this ampersand operator to actually print or fetch the address of every variable created in the computer memory? Now let's see. We can print the address of A, address of my number, even though it does not have a value yet, or address of my name. We can print the address of these variables by using what? This ampersand operator. And let's see how we can do that. If I say printf address of A, and I what? Now to print address of a variable, you use the format specifier %p. Okay, just get it like that. %p is used for what? Printing the address of a variable. Okay, so address of A, and then what? I reference what? A, and I do printf address of my number %p, and I say my number. I reference my number, and I do printf address of my name. I do %p my name. So what is this going to give us? It's going to give us, okay, now I need to put this in a new line instead. If not, they will all be joined together. So it's going to give us the address of A, my number, and my name. Now let's see. So now let me run it. Okay, okay, I can't really declare this guy without giving it a value. So let me give this guy value. So my name, say Michael. So that's what this error is saying. Cannot be. It's you need to when we get to array, you understand why this kind of symbol or something like this, what it means. Okay, but let's just keep it cool this way. So I'm gonna run.
Mike,
Yes.
I think I don't. Is it the name or the? I think it needs inside my name. You have a value to say what size. It says something about size.
Yes. No, no, no. Yes, I can actually put some values inside here. That is for me to this is what we call when you are actually specifying the length of an array. This is called an array. So when I put something like 50 here, you are specifying the length, that is the maximum characters or the maximum elements that this array can what receive. But
So can you
sometimes I
try with?
can, okay.
So can you try without Michael as the value?
Can I can I what?
And write 50 that you had there.
Okay, yes, I can do 50 without
Remove
giving
Michael.
Michael.
Yeah.
Okay. Yes, I can do it this way too, of which at this point now I've not, I just initialize that whenever I want to use this my name, I can give it um, maximum character will be 50 characters. And yes, it works. Yes, I can do it that way too. Now, for this guy, my number is saying new. Okay, let me give it a value. Okay, now I'm going to um excuse me. So excuse me, this compiler. Okay, so if we run the value, look at the very first value, the address of A, and this was the address, this data that we see here, 0x, and you see the address of my number, and you see the address, and you see this one, address of my name, and it's like the longest of it. Now you could see that every of the address, they are not what the same thing. They are all different. So that is one thing that is we need to establish, that every variable they have a special address given to them. And this is needed because it's what it uniquely differentiate them from one another. Okay, so we've established that each variable they have an address. And okay, there is an error somewhere. I said the ampersand. Please don't get it wrong. I didn't reference the ampersand operator here, and I'm supposed to do that. That was why the error came the other time. So it's supposed to be and. So it will fetch the address, and this one too, and this one too. So now it is correct. The initial value before was wrong. So please don't get it twisted. To get the address of a variable, you need to use the specifier %p, and then you use a ampersand in front of the variable. So I think I've established that now. I've corrected that. So you use %p, and then you reference the ampersand operator in front of the variable. So that's why you could see the full address was given. Now, if you see each of them, they start with the same thing, but the last value is different. This is C, this is 8 for my number, and this is B0 for my name. I think this is established now. Let me create another variable and call it float, new variable. I'm not going to give it a value, so that you can see that even if you have not given it a value, it has a location. already. So if I print f address of new variable, and I say %p \n for new line, and I reference and what new variable. So what are we going to have here? We are going to see the address of new variable. So if I run it, now you could see this new variable, it does not have a value, but it has been given an address, and no address can be the same, none of them. So that has been established. Now, why pointers? One thing that matters is the fact that there are some things that we can do in the computer memory that we cannot do there. We cannot actually do how will I say it? We cannot actually execute them with just the normal variables. Okay, we cannot achieve them with these normal variables. Okay, some things we can do in the computer memory, we cannot achieve them with these normal variables. Instead, we will need a special variable to do that for us. So when we want to perform operation on variable addresses, that is where the necessity of pointers come in. So what are pointers? Pointers are nothing but special variables that are used for holding the address of another variable. Okay. So what does this mean? It means that I can create a pointer that points to the address of A, and it will what? Hold the value, the address value of A, and store it to itself. And also that thing, that I can have another pointer that can point to the address of my number, and it what? It will fetch the address of and save it for us to use. The same thing goes for the other variables. So pointers, just get it, they are nothing but special variables that point to the address of another variable. If you don't want to use that, you can say pointers are special variables that holds the address or stores the address of another variable. So if you continue with the slide, it says pointers are special variables whose job is to store or hold the address of another variable. Okay, so we are still recapping again that for every variable created, they have a location and address in a computer memory. Of course, we can fetch or get the address of a variable by using the ampersand operator, as we have done here. And you could see we try to fetch the address of X of the data type int using this like this, just like we did. So the ampersand operator is actually used for storing the address of another variable, for fetching the address of another variable. Okay, so now in this same manner, we can create a star variable who can store this address and keep this special variable can have direct ability to manipulate the address. Okay, so pointers even have ability to what? Make changes. Probably they can change the address of a particular variable to another address. Okay, in fact, this variable can even have access or manipulate the value stored at this address it is holding. So this special variable we are talking about is nothing but a pointer. Now, I was saying some other time that for a variable that you created and give a value or initialize the value, that variable name is just a container. That variable that you created actually stored in the address is created. So if you take, for example, address of it is what? Address of it that what? 0x7FFF8799B5. That inside this address is a page starts. It is not like probably you see that start in A is actually the name variable related. Unless if you print, you do print f value of A percent B, we can then referencing A, somebody is typing, then referencing A, if we print one like this, we could see that we have a value of A. But the truth of it is that but this value is actually stored address. Okay. So we say something. Okay. So I think is the key. One thing I've said so far, every variable created they have an address memory. To print an address
Mike,
of a variable,
we are losing you.
you can't
Mike, we've not been able to hear you. I can't even see your screen. Your network is bad.
my network is okay. I can hear you guys clearly. Probably it's your network.
You've been breaking. If we check the chat, you see everybody's been complaining.
Seriously, yeah. It can be all over our networks. It's been breaking here too.
Okay. Excuse me. Let me try to change my network.
Mami Dele, are you back? Can anybody hear me? Hello?
I can hear you, but I don't think he's back. I
Okay.
think he's trying to talk, but I can't hear him.
Hear you. He's
He
saying
said
he's
he's back.
back, but we can barely hear him.
Network. Wow. We can't hear you.
You can hear me now.
Yeah, but screen.
It's still breaking.
Okay, yeah. I'm seeing your screen now. It's better now.
It's better now. Okay.
Yes, please.
Sheriff Ramatamu Jude, can you hear me now?
Yeah, I can hear you. I can hear you.
Wow.
Yeah. Yes.
It's better now. So where did I stop?
I don't even know because it was breaking badly.
Okay.
You stopped at the slide before you moved into the coding part or the compiler. You were on the slide.
I think I got it all to this new variable part where you printed the address. That is why I got it up to that
Yeah, the
point.
new variable. Yeah.
Okay. I'm trying to monitor the live too. Probably it's breaking, but the live is still on. Okay. So what I say is okay. I got a variable. What I'm trying to do now is summary. every variable created, they have a location in the computer memory, they have an address. And for you to fetch the address of a variable, you use what the operator. And if you are using printf alongside the default via SSP, okay, will give us the address in and form is the hexadecimal form. We can actually print the address in decimal form. Let us do some by printf address of address of A and say B for new line and a reference ampersand in decimal percent F address of my number. So percent D and I go ampersand number. So let me run it for the others. Then copy this ones. And then, so my name and this time around. So you see how it will look like in decimal form. Okay. So now if we print this guy, so let me just go and say decimal form.
Hello, Mike.
Yes.
Yeah, we are stuck on a specific slide. We are not seeing anything.
Okay.
I'm not even seeing any slide, and the communication is bad. You crack.
What
We
about
can't
this
hear
way? You
you
can't still
very
see my
well.
screen. Who's
We are
okay?
stuck on the compiler. Anyway, on my side, I'm on a compiler. That's what I'm seeing. But I can
Okay.
hear that you are talking about something else, but it's
Okay.
not what.
Give me 5 minutes. Let me switch to Glow. MTN is okay. This is so sad.
Don't be sad.
But I can hear you guys and everything is going fine. I don't understand this network. Okay.
If there's a tree around, you
But
could
you can
block line or
see
something.
the compiler
Is
screen
there a
now.
tree around?
I should climb the tree. I see.
I think audio is great, especially on our hands. The fact that you are probably streaming or something, say live video, I think that is part of why the network is bad for you.
Is it better now? Can you hear me now?
Yes.
Yes, we
Okay.
can hear.
Oh, that's funny. Hi. Sorry about that. These network people, they can just be frustrating. Okay. What I'm trying to say, where I stopped, is that we can print the address of variables, okay, by using the ampersand operator. And when you print with the printf statement, the format specifier you use to get the address is %p. The quiz that we're going to be having tomorrow, you're going to see something like this. So %p, okay, gives you the this format specifier to print the address alongside ampersand, okay, ampersand a or ampersand whatever the variable name. The ampersand operator fetches the variable, the address of that variable. Now, when you use %p, you get the address in this form, hexadecimal form. But we can also get the address in decimal form, which was what I was trying to do. So I have all the variables already, and I'm using %d this time around to get the address in decimal form. So if I run this now, you should see how it will look like. So look at it. Okay, this should be on a new line. Now, if you look at, you see address of A, you can see the decimal form, and address of my number. See the address of A, address of my number, address of my name, address of new variable. You see all of them in decimal form, so you can actually get them. In fact, you can still get them in octal form too. You know, when you reference %o, you get it in octal form. All these are possible, but majorly they are what's given in hexadecimal. That's why you use %p. Now, this is all about variable, and this is all about, okay, I can create a variable and I know how to get the address of that variable. Now, quickly, let's see a use case. Let me open another compiler at this time. If you have, okay, I come
Yes,
in.
I'm seeing something that looks interesting in those addresses there.
Okay.
When you print them in decimal form. What is the size of the what we've been dealing with the sizes of items? Integer, they said, what is it? 4 bytes.
Yes, integer is 4 bytes. Yes.
Yes. So I realized that there you have address of A, it ends with 700. Then
Yes.
address of my number is 696.
Yes.
So, well, but for the other ones, my name and new variable, it's 636 and 640. So it sort of says, I don't know if that makes sense, but it looks like it's allowing 4 spaces from 36 so that it can give the next address to another variable. And when you look at it, it looks like it gives it 4 spaces. Could it be because of the size of that type of variable itself?
Now you are actually, you are doing well in the sense that you are thinking far, and I like that. And that's it. That's the truth about it. Each of the address, there is something when we talk about C, we talked about the importance of data type, in the sense that for every variable that you create, you need to specify that data type, and it is very, very crucial to the C language. Now, for every data type, for the particular variable that you create, they have a particular amount of space reserved for them in memory, and that space is in bytes. And that is what we are trying to now understand at this point, because let's say we are starting with just a single variable. Now I'm going to comment out the other variables. I'm going to start with A. int A, and we're going to print the address of A in both the hexadecimal form and both the decimal form. So let me comment out the rest and leave just A. Okay. So now let us see something. If I run this guy, something is okay. Now let's see. Now we could see the address of A. This is the hexadecimal form. Now let me open up the decimal form. Okay, so address of A, the decimal form. Now this is giving us minus 1939 is ending at 6. Actually, this compiler is just giving a random value. Okay, so all we are just concerned with is the address. Now, what type of variable is this variable? What type of data type? We created it with an int data type. And what is the size of an integer in a 64-bit machine? Can anybody answer that? What is the size of an integer on a 64-bit machine? Quickly.
I think it's 4 bytes for integer. For long integer, is it 8 bytes?
Yeah, for integer is 4 bytes. Okay, on a 64-bit machine. For long integer is 8 bytes. Yeah, you're right. So what this is saying is that what this variable, this A, now that this is where this thing is getting interesting. This name container A is just the identifier that, okay, I have created an integer with the value of 30. Now this A, this variable, is going to be kept somewhere in the computer memory. So take it without understanding that this guy is what placed somewhere in the computer memory. So that somewhere in the computer memory is the address that we are talking about. And two, because of the type of this variable, which is an integer, at that position in memory that it has been kept, it is going to occupy a space there. It is not just going to be there for being there for being sake. So because of it is an integer, it's going to occupy 4 bytes of space. So it's going to occupy what? 4 bytes of space in the computer memory. So that is what is happening here, such that whatever thing that is going to happen to this variable, it will be at that address, and the operation will be according to this space it has occupied. Now, if I try to uncomment this second guy and I print the address, look at where this address ends. This is you just take a look at the hexadecimal form and the decimal form. So you are going to see that the address that will be given to this guy will be another 4 bytes allocated to it. That is my number. Now let me uncomment this address for it, and then the decimal form too. So if I run it, actually this compiler is just assigning random addresses. But look at this one here. This is 87C, and then my number is having 878. But I think this one might be confusing. Let's look at the decimal form. Now look at for address of A, 644. Okay, if you look at, you can see that from this side all the numbers are the same, but take a look at the last two numbers, 644. For address of my number, you can see that this one is now 648. It was the address, the position it is staying at the next 4 bytes afterwards address of A. So it is occupying an extra 4 bytes. So 4 plus 4 gave us 8 here. So another point that we need to put in mind is the address and also the size of space or amount of space that variable is occupying. And the amount of space will be based on its type. Another last example, let's check another variable. Let's look at this character variable. Okay. So you see that how much space does a car occupy in either a 32-bit or 64-bit? It's obviously 1 byte, right? So if you print the address of this car variable, so that's my name, and if you print there's a the decimal form, if you take a good look at it, this is A, it has given us 900, and now my number is another int, and it gave us what? 904. You could see it, that what is giving 904. But if you look at this one here, is because the type is car, it's like it's allocating or it's another space entirely for car variables, and it's giving 960. In order to make this clear, we can have another car variable, and you see that the space is going to take is going to be 1 byte. So let's say my car, or no, actually, let's see. No. The guy, if you look at this guy is actually occupying, is taking 50, right?
Yeah.
Okay. So this is 960. Okay. Okay, it's not clear. Because if you add 950, if you add 50 to 904, you should have 954. Let me create another variable, just a normal character. My car. Let me see. So let me call it printf address of my car. So %d. I'm going to do the two together. %d. The new line. So I'll reference the two and my car and my car. So this is possible too. We should add the two. So look at my car. This is the hexadecimal and this is the decimal. We have 753. Okay, this is for my car. And if you look at my name, that is the one having 50, that one is starting from 752. Okay, so the point here is, but the difference we can deduce from here is this my name, let's say it's starting from 752, and this my car, a car variable data type will occupy 1 byte, and you could see that it take up the next space for the car variable, which is 753. Okay, so and if you look at my number, the first int was 692, while the other one takes 4 bytes, the next 4 bytes, so it has what, 696 space. So all these things are actually some points that are actually necessary, and that makes it a kind of a unique thing about addressing and pointers. Now let's see something. Let me try to take this away from this guy and make it a regular character instead of an array or string. Okay, so if I run it from my name now, so okay. So what we have here, okay, is having, this is my name, and the position is what? 039. Why my car is coming first? 038. So from 038, this guy was given 1 byte, 039. And if you look at the other integers, for A, we have 044. And from that, okay, 044, why my number is having 040. So the address starts, this was created first, 040, and what? 4 bytes, another 4 byte was created for the second integer 044. And the same thing happened here for my name, the character 039, and what? 1 byte. It started from this side 038 for my car, and 1 byte was allocated for this guy 039. So I think this now makes it clear to see the relationship, how addresses are being allocated and why addresses are allocated. Because number one, the variable by their type, they have a special space, and that space, that amount of space that they occupy will determine where they will be positioned in the memory, and amount of space they will occupy, the amount of space they will take. Okay, this is necessary because of something we call memory, dynamic memory allocation. Because of C being a language that knows how to manage its memory, in that case, the aspect of amount of space, or the aspect of I check the address of a double. So I do printf. Address of my double. I do %p. Let me use %d because we can easily see. So my, and I'm referring, and my double ampersand. Now, if we run this guy, if something is wrong somewhere. Okay, I didn't spell the double very well. I didn't spell it well from here rather. So double. Is that how to spell double? Can somebody spell double for me? Did I get it?
I know the first one where you declared that was the correct one. The way
I was wondering. Okay, so now address of my double. Now let's see. This is ended with 456, 456, and we have my number 440. Okay, so this one was created first, address of A, because it's 436. Okay, now this other one was created, allocated 4 bytes. So 436 plus 4, that is what? 440. And then this character variable was created 441, right? And at that point, another character variable was created 442. Now I can see that this double is given another its space is given the size far from the other ones, starting with 456. Okay, because honestly, if you add 8 to this guy being the last guy in this set, that should be 450. Okay, 8 bytes, but it is giving it 456 from here, so like
okay,
extra
can
6
you
bytes ahead of them. Okay,
declare another double? Yeah,
yes, that's
after this.
okay. So let me declare another double, my double 2, and to print the address, so I do print f address of my double 2. So I do percent d, my reference, and my double 2. Okay, so these guys below, let me take them up so that we can have an even outline of where these things are coming from. So I'm gonna put these guys here. Then I'm gonna take this one up. I'm taking this one up too. Don't get lost. We all of these are still part of how pointer works, so we are still in the same game. If you understand this, when we even get to the pointer itself, because after all, pointers are actually address itself. So it is still the address we are talking about now. With this overview, we should be able to have a solid foundation. So if I run these guys now, so starting from here, this is my number, okay, and okay, this is address of A 532. Okay, my number was created first, 528, and what? 4 bytes was added. We have 532. Okay, and then my name, that is the car variable, 527, and this one was created first, 526. So we have 526 created, and then we have 527 created. Okay, 1 byte, and we have my number starting from 528. So I think what is happening here is coming like this is the character variable 526, right? Now this one was 527. Before we add the my number created, which is 528, like a 1 byte space was what was given before this one was created, right? Because if you add 4 bytes to this, you should be having about that should be 5353. If you add 4 bytes to this guy, that should be 531. Now let's check the double. This is 504, and the other double, this is what? 512. Could you see? So 8 bytes added to this one, we have what? 512. All we are working here is how much byte all these things are adding accordingly, and the byte addition or the space allocation is based on their what? Type. So the first double, this one was created first, 504, and another one was created, and 8 bytes added to this by the end, we have what? 512. 8 bytes. Are we together, guys? Are we trying to at least can we get some points here from what we are doing so far? Is there any confusion somewhere, like clarification somewhere?
Yeah, I think what I'm seeing is the bytes are being the spaces are being added accordingly, but where that space is, where that address is really random or it's based on the computer. We cannot. It doesn't look like it's something that we are able to determine.
Yeah, the extra space before the creation of a new variable, right? Is that what you meant? Like this is
Yeah.
my
So
car 526, and this is another car variable 527, because they are the same. So they follow the interval, the sequence. Why when we add, we have number integer, it's starting from 528. Meanwhile, the last value is 527. So it's starting from 528. And if you add 4 bytes to this guy, we have the next integer, which is 532. Okay. And if we are taking it from this guy, from the double, because the double is the one starting the 500 series something. If we start from the double 504, if we add 8 bytes to the next double that was created, we have 512. So if we are taking 512, if we say okay, the next thing that we are seeing on the list is a car variable. Of course, what we have here is 526, and difference of 526 with 512, that's about how many bytes we want to talk about. If you do 526 minus 512, that's about 14 bytes. 14 bytes distance. So I would think this is like a random generation from the compiler, and probably we can just try with our VI and try to see the size, I mean the address, if it's what a change. But all that is needed is whatever starting point this thing is coming from. If you create the same variables, the same data type, if you try to see how much space they are collecting, you should see the difference or in the byte, the number of bytes, because at least we can compare this integer with this integer, and we can see the difference in what byte. The first one is 528, the other one is what 532. So addition of 4 bytes. So it's like they are grouped in sets in the location that they are in memory. They are grouped in sets. They follow each other. I think that's what I can just say. I'm not really getting a clear view of it, but we'll understand soon as we move on, Sha. Okay. So now let's continue with our pointer. So now you could see how at least with all of this, it's a bit complex. Let's put it that way. How all of these addresses look like. You can't really just cram all of these addresses in your head. You can't really just put them and you want to memorize. You can't even memorize two completely. Talk less of you want to memorize about 30 variables with their addresses. And that is where pointers come in. Pointers come in because they are just the same way we will have a variable, although they are declared or created in a special way. But at this point, pointer will give us the ability to have a simple name to give to a variable, have a simple name to give to the address that pointer is pointing to. So if I do something like, let me open another compiler. If I have something like I create this variable int a or int num, and I set it to num is 60, and I want to create, and I do so, let me just say printf address of num %d and num, and I do printf value of num %d, this time num. Of course, we have the address and we have its value, but I can actually just have this address stored somewhere in a special way, such that through this address I can have direct access to this value, because what we have established so far, this address is actually what stored, this value is stored in this address. So now let's see how pointers work. Let's see how we can do that, and that's the work of a pointer. So look at this image illustration, what a pointer does and how it works. So this is a pointer variable, and this is how to create a pointer. So int asterisk ptr equals ampersand b. Let's say it's pointing to what? So this means this pointer is pointing to variable, an integer variable with the name b. Okay, so this is the pattern for declaring and initializing a pointer. So in this case, a pointer is pointing to an integer variable, and that is why it is having the int data type. Okay, we are coming there. Now, look at it, pointing to the address of another variable called b with data type int. So let's assume this is the address. This is the variable int b, and this is the address of int b. Okay, now it is in this address that what we have the value stored in b, and the value is what, as in this case, 65 value at the address. So what is it saying? Logically, if the pointer can have the address of a variable, it definitely can have access to the value of that variable. After all, value of every variable is actually stored at the address. So with this illustration, we can see that this pointer, it points to the address, but in the same vein, in the same way, it has access to the value at the address. And there is a way we can what? We can actually make a pointer have access or get the value of a variable at the address it is pointing to. That concept is called pointer dereferencing. We'll get there. So now let's move on. Pointers typically hold the address of another variable. That means they point to the address or location in memory of another variable. Pointers have data types too. Sorry, not really. Actually, the point is, while a pointer can point to a variable, that pointer must have the same data type of that variable. So what we are trying to say is that the data type that a pointer must have, it must be the same with that of the variable it is pointing to. So an int pointer cannot point to a car variable. That is what we are trying to say. A car pointer or a pointer that is pointing to a car, with probably you are trying to create a pointer, you start with car, asterisk car pointer as the name. It cannot point to a float variable. It must point to the same type. So if you look at this diagram again, you can see that this data type of this pointer is what? Int, and it is what? Pointing to the address of b. So with this case, it is only an int pointer that will point to an int variable, and it is only a character pointer that will point to a character variable, or a floating point pointer to point to a float variable. So that is just the pattern and the technique there. Although when we go further, there are some points whereby we can have a pointer that can point to any variable, any type, any data type. And that type of pointer is called a void pointer. That is void pointer. That pointer that has a data type called void. But coming to this level first, let's get understanding of this. If you are creating a pointer to point to any variable, it must have the same data type of that variable it is pointing to. So now, when we want to declare and initialize a pointer, this is the general syntax. We have data type, and this specifies the data type of the variable this pointer will point to. Now, this asterisk symbol or operator is the symbol, or it is a symbol used as a special way to declare a pointer, because we said something that a pointer is something like a normal variable, but in order to differentiate a pointer from the other variable, to make it special, we need to what? Put something. So this asterisk symbol makes it to differentiate a pointer from a regular variable. And then we have what? The pointer name. So the name of the pointer is given here. So we have data type asterisk pointer name. For example, we have int. This is a what? A pointer pointing to an int variable. That is, it would what as you create this pointer, it is ready to point to the address of an integer. As you create this one, car asterisk car pointer or PTR, it is ready to point to the address of a character. That is the whole logic we are trying to get here. What we need right now to get the basic understanding of how to create a pointer and how pointer works, what is the function of a pointer. This is necessary before we move further, because once you get the basic, the other ones become easy. And also we've been able to establish how to print the address or how to fetch the address of a variable. So let us create a pointer now with what we have learned before we move on with the slide. So I can say, for this guy that I've created, I can create a pointer now that will point to the address of num, this integer variable. So I can say printf, no, sorry, I can say int num pointer. I'm giving it this name. Okay, so we have the data type, don't forget, the asterisk, and the name of the what? The name of the variable. Sometimes some people can create this way. This convention works too, where the asterisk is closer to the data type and you have num pointer. Either ways, it works. So, but I'm going to use this other one because this one looks more easy. I just like it, yeah. Let me put it that way. So num pointer, and I would say equals to 10. Remember, what makes a pointer to be a pointer is that it is storing address of a variable. You cannot say it is pointing to num like this. It will throw an error. So you need to what? Specify the ampersand to what? To get the address. So it fetches the address of what? Num. So that is what we established here. So now mind you, if I want to print the value of what? This guy. Now, if I want to use this guy now, I don't need to be putting the asterisk. Although there is something whereby if you put the asterisk and you're trying to print out something, it will give you a value. So, but we'll get there. But if I can do printf now, I can do printf value of num pointer, okay, and then I'll reference %b. I want to print it in decimal. We already know that what it is going to give us, its value is going to be an address, and it will be the address of num that we have created. So I'm going to say, hello guys, are we still there? Okay. Before I'll think that the network has done me something again. Okay. So if I run this guy now, what we should see should be the same value with this. And let's confirm if it is true. Or even if the compiler gives another random value, we should see the same value. So we are printing the value of this guy now. Okay, so run, and Okay, something is wrong somewhere. Can somebody guess what is wrong? I won't say anything. We are supposed to see the same value, but why are we not seeing it? Quickly, quickly, 2 minutes. I've
You
seen the
didn't.
error.
You didn't. You didn't print the
I didn't reference
print.
non-pointer,
He
right?
didn't reference non-proton, yes.
Yeah. So let me do that. Good. That means we are following. So num. So could you see we have the same value, and that is because it is storing the address of num. This guy. If we want to do anything to this guy, this man here, we can have access to it via this pointer because it has the key to manipulating this value here. And that key is what? The address. So we have been able to fetch the address of this guy through this pointer. This pointer is holding the address of this guy. Is holding the unique value of num variable, which is an integer. And what another thing to take home is what it is having the same type with this guy, and that is what will make it to be what to be valid. If I try to change this guy to car, there will be an error, of course, or probably is even running, but this is wrong. You cannot have a card pointer pointing to another thing. I will assume that this compiler just made it to run. You cannot have this thing like this. So it must have the same type. So that has been established. So how did we get this? We are saving the address using the ampersand into what? We are assigning it. We are assigning this address into the pointer variable. Okay. So now let us move on with what we have here. Sorry. So if we move on, okay, the general syntax for assigning a value to a pointer variable, we have done that already. You have the data type, the asterisk symbol, pointer name, and variable to point to. So, for example, let's say we created a variable called x with data type float, and it is holding a float value of 3.2345. So we can declare and initialize it this way. This is a float variable that we created, right? Okay, this is a float variable. Now, in this same way, we can create another special variable pointer, which can help us hold or store the address of this float variable. So using this syntax, float, this asterisk symbol, and then this the name of the pointer, and then referencing the address. In this case, it has held the address of this guy. Now, the scenario that has happened here is that we have created a pointer variable which is holding the address of what? A float variable. Now, ampersand symbol is what? Is what has helped us to fetch the address of x, and it has stored it into what? This guy. Now, we have passed all of this, given a variable name and initializing, declaring a pointer, initializing a pointer. Okay, I believe we understand the difference between declaring and initializing. So if peradventure I did not, let me say I just do something like this. I only declare this pointer this way. So when I give it a value this way, I have initialized it. Okay. So I assume we know that already. Now, if you move forward, let us now try something. Before we come here, let us let us see something like, how about if we said something that with a pointer you can actually manipulate the value of this guy through this pointer. Now, there's something called pointer dereferencing. Okay, so pointer dereferencing. whereby we can say printf. Now this time around, pointer dereferencing means fetching the actual value stored in the address that what that pointer is pointing to. I'll come again. Pointer dereferencing is what fetching the address and fetching the actual value that what a particular pointer is holding, the actual value of the address or in the address that pointer is holding. So for example, we have this, let's say we have a pointer called my num pointer, and we want to fetch what exact value it is holding. Okay, what exact value is in that address it is holding. Remember, pointer actually hold address. Pointer points to address of another variable, but we can get the value inside that address through what we call pointer dereferencing. And pointer dereferencing is just whereby you reference that pointer by using that asterisk. When you use the asterisk in front of that pointer name, you are referencing the pointer, and you are what getting the actual value in that address it is holding. So in this case, this pointer is going to get the value of the variable it's pointing to. It will get the value itself by the fact that we have used this asterisk operator. So now let's see this. Let's see how this is going to be. So I'll say value at address, a value at pointer address. So, and I'll do %b this time around, and I'm going to what this time reference num pointer. Remember, the pointer we have here, the name is num pointer. What is this going to do? It's going to fetch the value that is inside this address. And what is the address? The address is what? It is pointing to this num. So with this now, we should see 60. Let's see. And you can see value at address 60. So something has been established here. Pointer have access. Once a pointer holds an address, it has access to, let's say, the life of that variable. It have access to everything about that variable. In fact, I can change the value of num through this pointer, in the sense that I can say printf, I can say asterisk. Now I'm dereferencing this pointer and totally I'm changing the value. So I can say whatever value is in address, I'm coming, somebody's raising up hand, okay. Whatever value is in this address, I'm saying change it to 78. Now if I do printf from this line, I say value, I'll say new value at pointer address. Okay, I say %b, and I reference pointer, and I'm going to now, let's say, let me print the value of num this time around. So value of num, a variable itself. So %b, so I'm referencing num. Now let's see what's going to happen. Now you see, look at the previous value. Now it's a new value at pointer address 78. We changed it. Now look at num variable itself. What it has done to 78, of which initially it is what 60. Okay, somebody is raising up, and yes, quickly.
Thank you. Thank you very much, Mike. I'm looking at the outputs for the code on line 12, comparing that with what we have on line 15. So line 12 is saying value of num pointer %d, and what it's giving us looks like the address actually in the output when you run it. So I imagine that long figure there is not the value, but that's the address, if I'm not wrong. Since we use %d, it's giving us a decimal.
Decimal
Value,
value.
right?
Okay, that is on me. That was a mistake. It should supposed to be address. Sorry. Okay. Yes. It's not. I'm going to clarify that. Yes. Okay. Let me break it down. Yes, it's actually the value of non-pointer. It is correct. Now, this is taking us back to what actually are pointers. This variable here that we reference here is taking us back to what kind of variable is it in the first place? It is a pointer. Okay. And what does pointer, what do they hold? What do they hold inside of them? They hold the address of another variable. So that is why its value here is actually what? The address of this man. And that is just the definition. And definition of pointer is pointer are what? Special variable that holds the address of another variable. So this non-pointer, its value what is the address of num. That is, it is pointing to num. Is that clear?
So but look at what line 15 is outputting.
So line 15 now, you could see by the name of line 15 is saying value at pointer address, or I can say actual value of variable. What this thing is saying is the value at the address, in the sense that this address that this pointer is holding or pointing to, there is an actual value there, because in the first place we know that this pointer is pointing to the address of this variable, or pointers point to address of another variable. So it's just like this pointer is holding this address, okay, but inside this address there is an actual value, which is the value of the variable it is pointing to. This is where pointer
So
stuff of a thing looks complex a bit, but just get it. Pointer holds address, but inside the address is the actual value of the variable it is pointing to. Now, pointer holds
so in
address of a,
essence, in
okay,
essence, if you want to get the address, you don't use the asterisk. If you want to get the value that the pointer, the value of the variable that the pointer is housing its address, you use the asterisk
perfect.
when you are
Yes.
naming the pointer. So that's the clarity I wanted to get, because initially they both had the same wording, but they were giving us two different outputs.
Yes, exactly. So you
Okay.
you are correct. But probably I can just say num pointer this way, so you can, that could probably give you um an overview. But that's just, you need to, when you are getting the actual value in that address or at that address, you use the asterisk. So, and that is called dereferencing. You are dereferencing the pointer, okay? But when you are getting you are viewing the value of that pointer itself, the pointer itself, not the value at the address. So the pointer itself, then you do the name of the pointer alone. So the name of the pointer alone give you the address it is pointing to. While asterisk with the name of the pointer, it gives you the value at the address it is pointing to. Okay, somebody is raising up hand again.
Yeah, Mike. I think at this point, going back to the slide, I would really, I don't know. I feel like based on the explanation you gave, uh, I wouldn't put that star there in line number, that asterisk in line number 15, when we are saying value at pointer addressed asterisk num pointer, because earlier you said the the at line number 10, like the declaration, we can even put, you said we can even put that asterisk next to the int or closer to this one. So it's, to me it says these are two separate things. The first one is the declaration telling us that we are declaring a pointer. So this other one in line 15, it says uh, we are trying to get a value of a variable at this address. So to me, it doesn't say that we cannot point to the pointer by saying it's a star something.
Yeah, Mike, I think Sheriff has his hand up. Looks like he has network issues again. Ramothamu, can you hear me, Sheriff?
Yeah, Jude, I can hear you, but I don't think Mike is here. Probably network.
Jude, can you still hear me?
Yes, he just came back. Welcome. Like we had network issues again. Mike, confirm you can hear me. So let's walk.
I think he's gone again. Can't hear you, bro,
Why
at
can't
all.
we? Oh, can't hear you. Funny. I hope you're not muted.
He
What
can't
about
be
you now?
muted. I don't think he's muted.
And
We
what
had what
about
about
now?
now, but we've not had anything else.
Okay. Can
Can
you
see
see my
your
message?
screen though.
The thing is fluctuating. The network strength seems to be
Is
fluctuating
it
from what
better?
I can see here. It goes from amber to green, green to amber. I think when it goes to amber, we cease to hear you.
Okay. How about now?
Brother,
Is it clear now?
blessing now that tree
Yes,
go
it's
see
better.
climb. Oh.
Honestly, I can hear you guys. I can hear everything you guys are saying.
Yeah, now we can hear you very well. Please write on.
Probably the network is okay now. Ramotamu, can you hear me?
Yes, Ramotamo had a question he was asking before you went off. I don't know if you can ask the question again, then you clarify.
Yeah, I can hear
Your
you.
timekeeper was trying to call your attention then.
Okay. Ramotamu was trying to look at the output on line that's line 19, I think so. Where line 15 rather. He was trying to look at probably because I added this asterisk. So why I added this asterisk is because if you want to get the actual value at the address the pointer is pointing to, because of this long English is making this thing look as if it's complex. But one thing I say is just get the fact that pointer holds address of another variable. Just know that one. Once you know it, any other thing that comes forth is built upon it. Okay, somebody is raising up, and so I'm coming. What you need to know is pointer. If you reference just the name of the pointer, just like this, it is the value of the pointer, because pointers, they are holding the address of another variable. So if you just reference the name of the pointer this way, like this, it will give you the address it is pointing to, or the address of the variable it is pointing to. But when you need the actual value in that address or at that address, you will need to dereference the pointer using asterisk in front of the name of the pointer. That is the difference. So if you dereference the pointer using asterisk in front of the name of the pointer, it will give you the value of the variable of the value at that address, or the value of the variable it is pointing to. Okay, so who is raising up hands? Okay, Sharif, come in.
Yeah,
Yeah.
okay. All right, thank you. So I think we need to further like understand what this value of a thing mean. Does it mean that the fact that this pointer that is pointing to this norm integer, is it giving us a value 60, which is an integer because it's pointing to an integer? And does it mean that if it is a character, it will have the value of a character, say something like A or B or something? I think we should probably try pointing to a character and see, so that we get a better picture of what the values mean.
Okay. Honestly, we are gonna try every other character data type. But what you need to know, okay, is what you are seeing here. Firstly, from this line, address of norm. This is the address, and the value of norm is what, 60. The value of what, norm pointer, is what, the address of norm. One thing I feel that we are still not getting is
Hello?
the meaning of pointer itself.
Okay. Hello?
Yeah,
I actually understand the difference between like the
I can hear
address
you.
and the value. I do.
Yeah.
I just want to know that I want to know if the value is dependent on, we are saying 60 now, like, and then 78 because we changed the value from 60 to 78. I understand all that. I understand the
Yes.
difference is the address is different too. I just want to know if this value is, we are saying this value because this is an integer, or the value are always going to be integer, say they are always going to be 60, whether the
Okay.
pointer is a character or an integer or a float or whatever.
Okay. Okay.
Yeah.
Let's create another variable, and it will be a character variable. Okay. So this is the name of the variable, right? My car, and this is its value u, right? So I'm going to disable this pointer the referencing first, and this one, so we can see something. So all we have is what, the norm variable and its value 60, and we are having the pointer to norm, which is holding the address. Okay, now this is another variable, my car. So I'm going to create a pointer that will point to my car. So I'm going to say, remember, they must have the same data type. Okay, so I'm going to say car. I'll say my car. In order for me to be able to identify, I'll say my car pointer, like this, and I would say it is pointing to what, the address. So pointing to the address of my car. So what am I going to print now? I'm going to print f. I'm going to print f address of my car. I'm going to print it in decimal form, %d, and I'll pass in my car, and I will say, okay, so I'll print in the address, so I will have to use the ampersand, don't forget. So print f address, or I would say value of my car, so %b, so it should give me the value of my car. Okay, now what am I going to do next for the pointer? Let's run this first so you see what is happening. So we have what, address of my car, this address, right? You could see that it's different from what is here. Okay, so it is 1 byte. Now,
I think you forgot to put a star somewhere. An asterisk.
perfect. Yes. I haven't even printed the pointer first. I'm still working
And
on the
yeah,
marker variable.
it's. I think it's. I don't think he forgot, but because he's still able to get the address of that, like we did with the integers.
Yeah, I
Is it?
I I, I haven't even started working on the pointer of my car.
Yes. Yes.
All that is printed out here. If you look at this address of my car, this is printing the direct address of this guy. And this is value of my car is printing the value of this guy. And probably what could different to you is I reference percent D here. Honestly, I'm supposed to reference percent C. So what is giving me here is what the ASCII value of U, character U,
Yeah. I, I
117. Okay.
yeah, I saw that, but I thought you were doing it purposely with that percent D to
Okay.
get the 117.
That was a mistake. It wasn't on purpose. So if I reference, you see the value is what U. Okay. So this is on the my car variable itself. Now let's work on the pointer. Okay, so if I come here, so let me just do this line, my car pointer. Then I say printf value of my car pointer. So I'm printing in decimal form, percent B, new line, and I'll what? This time around, I'm printing value of my car pointer, and the value should be the address of my car because I have referenced his address here. So I am assigning the address of my car into my car pointer. So I can just call the name of my car pointer. Okay. Now let's run this first before we move further. Oh, new line somewhere. Okay. So value of my car, and I have what I'm on my car pointer. Sorry, I'm using this one to differentiate them. Okay, so now this is on the pointer, and you see the value is the address of, you can see it's the same address with what my car established. So the value of a pointer is the address of what another pointer, another variable. Sorry. So now, if I want to get the actual value stored inside this address, so if I say printf actual value at pointer address, okay, so I now say, now we know that I am dealing with a character. So honestly, if I reference percent D, I'm going to get the ASCII equivalent in decimal. Okay, so I'm going to reference percent C because I am dealing with a character. So if I do this way and I say the reference my car pointer, so what should this give me? Should give me the value. So if I run this, now you can see that I have actual value at pointer address, and this is what U. Is this clear a bit? So we can get the value of that at that address. So this value is coming from this address, of which this address is the address of my car variable. Any confusion somewhere? Any clarification?
All right. Thank you very much. So if I got you right, if I'm to paraphrase, yeah,
Okay. Yeah.
the pointer's natural use in its natural state is to store memory address.
Perfect.
So when you declare it without putting the asterisk, that is its natural name, it retrieves the address for you. But when you now want it to retrieve value for you, then you need to dereference it to the asterisk.
Yes. And to correct your English, it's not like when I declare, when I reference it ordinary with its name, it
I
gives
can't hear you
me
again.
hello.
Not declaring. I think
Uh,
I used the wrong.
exactly.
Um,
Because when you declare, you must use the
yes,
yeah.
yes,
Okay,
the
I
print
think that's clear.
statement.
Okay. So another person, Ramutama, are you cleared?
Yeah, I'm actually clear with all what we have done, but I realize it really requires a lot of concentration to,
Pointers
you know,
need enough
Eh,
yeah,
focus.
yeah,
okay.
address
So
of the address of that, and the terminology around it is really crazy.
Yeah. Okay, Sheriff wants to say something.
yeah, I was going to ask you, yeah, if you could scroll up on this side of the code. Like I'm not seeing the part of norm at all.
Okay.
So you initialized norm as okay, okay, all right. I wanted to see the value of norm there. I did not see it then. So what I thought initially was that when you printed the value of the pointer with the asterisk, it changed, like it was not 60 or something. That is what I thought. Like I thought this norm from the initial declaration, you did not give it the value 60. I thought printing the value of the pointer just came up with 60. That is what I thought. But now I see
Okay.
that. Okay, it is
Yeah.
understood now. I get it. Thank you.
Okay. So we can do something now. Like you'd have been asking some question like why pointers in the first place? Why do we need pointer? Why what is the purpose of pointers? Let us do something, a quick check on something. If you have used scanf before, if you look at scanf, so let's do an example with scanf. So I'm going to say a program to add two numbers. So I'm going to say first thing I'll tell the user, please enter two numbers on a new line. Okay. So I'm going to use scanf, but before that, I need to of course create a variable that is going to store those numbers inside of itself. So it's an integer. So I'm going to say int. I'm going to say int first comma second. So I'm not giving them any value, or I can declare them this way: int first comma second, and I can say first equals second equals 0. This is possible, guys, in the sense that 0 will be assigned to second and the value inside second will be assigned to first. So what is this saying? First is 0, second will be 0 too. You want me to quickly print out that, so I can do that. I'm just showing you some possibilities in case you see these things so you won't get just lost. Just know that it is possible. So I can say first, and then let me print the two at the same with single print new line and percent B new line. And I can say second. So if I run, you could see the two is 0 0. So first is 0, second is 0. So this is possible. Don't get lost or confused. So we can now say something like, okay, so we have the two variables and the prompt is please enter two numbers. Now we'll give them opportunity to enter the number. So we say scanf and we do %d because we are receiving integers, %d. Okay, and now what next do we do here? We are going to reference the address of what? The two integers that we want to receive. This is where this thing should become clear to you, that the actual values of variable are stored at the address itself. So if I say and first, this will what? Retrieve the address of first and then what? Put the value inside there, that address, and then retrieve the value as address of second and put the value inside. So and second. So if this should run, the values will what? Will be given. And then if I do print f now, I say value. Okay, I can now say total equals, because we want to add two numbers. So %d. Okay, so total equals %d, and on a new line, I can now do first plus second. But before that, let's say we tell the user that this is what you enter. So I can say print f your first number. So I reference %d, and on a new line, I call first for that one, and then I say print f your second number, and then %b, I'm referencing the second. Okay, so we've been able to establish that. So that means whatever the user enters is stored in the address of first and likewise second. And I'm giving the user back to see what he or she entered. The computer has thrown it back. And then I'm now printing the sum, or I'm going to call it sum of the two. So I'm saying first plus second. So if we run this guy now, so look at the code from the top. Two integers, first was created, second was created. The two was set to 0, the initial value. And then we see the prompt, please enter two numbers. And scanf collects the two numbers, stores them into the address of the two variables we created above. And then we are printing to the user back the value they entered, and we are printing the sum. So let's see. So if I run this, so it's coming from this line. Please enter two numbers. So I enter the first one, 70. Enter the second one, 85. So you could see your first number, 70. Your second number, 85. And sum, 155. So what does this mean? This should make it clear to you and establish the fact that values are actually stored at the address. So the name is just like just a cover or a container. It's just there. Sorry. And why is it that there must be an address? The address, aside the fact that the address is like the place in memory that the computer can always go to get values from any variable, also that location, it has the amount of size of space it occupies. Okay, just like if you have a room, or I mean a house, you will see that the house, okay, somebody's raising up and I'm coming. You see, if you have a house, you see that there are different rooms in that house. So in that case, each of those houses, they have different tag and assigned to different person. So, and each of those rooms, they have the amount of space that is what inside of them. Just just need to understand this thing, and by the time as we go on, it becomes clearer to you. Okay, Come in, Sheriff.
Okay, thank you. Does it mean without the hand in the scanf line 15, we are not going to be able to take in values?
If you put without the and in the scanf, you are just passing the name of the variable itself. You are passing the value. It's inside. You are like passing zero. If you run it like this, probably it will throw an error or it will give us a wrong output. And let's see. This is for second. So I entered 75 and I entered 90. Could you see? So this is giving us what? Segmentation fault. And what is happening here? Now, there's something that will always happen when you try to access an address that does not exist. One, there will be an error that will be given by the compiler. Now, what has happened here is that scanf went through, the prompt was given, and the user entered 75. It picked that 75 and stored it inside what? It searched for address of if any address had been passed to it, and it saw the address of this variable called first, and it stored it inside. Okay. Now the second number was what given, and it's looking for if there's another address, and then it now saw this guy. Instead of it to be an address, it is not an address. Instead, it was another thing. So now scanf is now trying to access an address that does not exist. So this is like accessing something that does not exist. That was why it threw this error segmentation fault. On a normal day, if this thing was tried, like use without compiler that can catch errors like this, the computer might just spoil. It might just um, destroy or crash the computer totally, because that's like a critical thing when you're trying to access something in the memory that does not exist. So when you are doing this, you must reference the address, because it is at the address values are being stored. Any other person? Is that clear, Sheriff?
Great, thank you. Understood. So it means every time we want to use scanf, we have to use the ampersand alongside the variable.
Yes,
All right.
exactly.
Anyway,
Thank you.
in addition to Sheriff's question,
Okay.
I realized that if we use scanf, but we are dealing with values that are string values, we don't use that ampersand. It takes the the variable itself. So supposing second was a name, say it was Mike, we're going to just put second there. So that obviously says it works differently for strings. But I don't know if you can add anything with regards to explaining why that is the case.
Okay. You want me to deviate a bit? Okay. For strings, it actually works differently. And let's do something. Let me create a variable called my car. Okay, my name rather. I'm going to call it my name. And I'm not going to specify the size. So I'm going to just give it, let's say, Michael. Now, this why this works this way is because it's something between the similarities or some similarities between um, arrays and pointers. Now, if I take off this guy, um, okay, sorry, since we are okay, yeah, because we want to, what would we want to do here? We want to pass this character into scanf, so let's give it a size of 50. Okay, we need to, and I can clear off this guy since we are not using it, and just focus on. So this program what will ask the user for the name for their name. So the program that asks user for their name. So we can say printf enter your name. And then we can say scanf. So percent. Now, when you are referencing string, you use percent %s. Okay. So at the point, we are not going to use the ampersand. I'm going to explain that in a minute. So if I say my name, now all clear, all good. So enter your name, I see. Okay, this program is not even complete, although it will just collect the name and it will not do anything with it. So I can now do printf here. So your name is, so I'll reference my name here. Okay, so what we'll need to specify %s, so it will print the string. So the character variable, the prompt, scanf, but this time around is not collecting and ampersand. So at this point, it's giving this. Okay, so starting Michael, and you can see that it gave us the result. Now, what is the difference between passing strings to scanf and passing integers? Now, the difference is that when we are passing, now this string now is not like your regular string or character that as you know, when you're passing a character, definitely you will need to use the ampersand. Okay, but we are passing a string. Automatically in memory, when you create a string, before we go further, we should know that of course strings are what? Are a list or combinations of characters. And when we get to array, this is how array works. You can create an array in this form. That is, this is that telling you that you are creating an array that is going to accept a maximum of 50 characters. You can create an array of numbers, but this is an array for characters. That is, what is going to receive is going to be characters. Arrays are meant for creating data of similar or the same type. I come again. Arrays are used for creating data or list of data of the same type. So that is why this array that is here is obviously going to receive a maximum of 50 characters. When you coin 50 characters together, it forms a string. Now, why is it that we are using strings inside scanf and we are not using the ampersand to actually get the address? This is because on arrays, the first value, because arrays, another thing you need to know, arrays are indexed in, that is, they are numbered, they start from 0. Okay, so this is from 0 to 49. You are trying to like get the value of this array from 0 to 49. So, excuse me. So what I'm trying to say now is, why didn't we pass ampersand here? Automatically in arrays, the first value, the first index of an array is pointing to the address, is a pointer to the address of that entire array. Somehow 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 complex. Okay, now let's see. Let's see why. Let's see. Let's do something. Let's do printf address of my name. So I'm going to print it in %p so that you can be clear and you won't be. I'm going to disable this scanner because it will run first. It will overwrite. So let me just put this. And I'm going to pass in my name. Okay. So now watch. I'm going to disable this. This should give us the address of this car variable. Look at address of my name, and it's giving us the address without passing what ampersand. Now, if I check for the address of, if I do printf, now I can print the first value of my car. Let's say I come here and I say my name, rather, not my car, my name at position 0 is equal to, like we have entered into array. So at position 0 is equal to this first character M. And I say my name at position 1 is equal to I. And I'm saying my name at position 2 is equal to C. So let's leave it this way first. If I come in and say address of my name at position 0, I say %p new line. So I say my name. I'm now referencing the first address. So let's see. Okay, now this is different now. This is giving me something different. Now, this is the entire array, the entire my name 50 array, the entire array. This is giving me the entire array. But if I'm single-handedly, if I break the array into, okay, this is the values of the array, that is at position 0 is M, at position 1 is I, at position 2 is C. This is like characters now, the individual characters. So I'm not dealing with this entire full string. If I need the address, I will need to what? Pass in the ampersand. So like this now, this should give me the full address for the two. So look at, this is the full entire array, and this is what 0xf7ffE4, and this is what 0x. Now what am I trying to see here? This, the first value of an array, the first element or the first index in an array, the address is the same as the address of the entire array. And when you are printing the address of an entire array, you don't need to reference the ampersand operator. You just need to reference the name. When you reference the name, it will give you the entire address for that array. I think that was when we are trying to get the address of, when we started this, I think this one, when we started this that we did the other time, the my car variable, where is it? Okay, before we changed, that was what was happening in the first place. People are lost. Hello, guys, you are lost, right?
No, none here. Yeah.
But Ramazamo, Jude, any confusion somewhere? We have entered array actually indirectly.
It is just I hope you're like looking at the time or something and check the chat.
Yeah. I can't even really see. We have 5 minutes. What did Jude write here?
Wow, so you've not been seeing the chat. Goodness. Okay.
I will need to be switching to the before I can see anything. That's just it. I will have to be switching. Let me think what is happening. Um, okay. Okay, yeah. Mm. Okay. Ramatamu, did you get any difference between why we are using ampersand and not ampersand in strings?
Yeah, I got it.
Okay. Now we can do something. Let's do this and we'll call it a day.
I hear you anymore.
You said Jude, what did you say?
I hear you anymore. That's when I started again.
You can't hear the others can hear me. Ramatamu, can you hear me? Sheriff, can you hear me?
Yeah, I can hear you.
Can hear you too.
Jude is your network. It's Jude network. Oh. Now, quickly, we can access this value at this position of the array. In fact, let me try to put more values because we have 50. So I can say int num at position 3 equals h. So I want to spare Michael. So my name at position 4 is equals a. My name position 5 is equals e. My name position 6 is equals okay. Now when we are creating a string in an array, there is always something called the end of the array called a null pointer. There's something called null pointer. Now this null pointer indicates the end of a string array. So it indicates the end of a string. Are we together, guys? So if I do printf value of my name, in fact, I can do a while loop. So I can say, okay, I can create a variable. I can say int I equals 0, and I can say while I is less than so I want to get the end of this string. So now look at, I can actually count how many elements is inside this array. Now this array is actually 50, so I can see why I is less than or equals to 50. If I print that, it what print about 50, all the 50 spaces position in this my name array, and it will print from this point here to this point, and when it gets to it will print all the 50. Even it will print the end of this string, but at the same time it will continue and print some junk characters. Like, let me do something. Let me say my I equals less than or equal to 50, and I say printf my car, my name at position. So I'm going to use position %b, and I'll say equals %d. This looks tricky. What am I doing here? I'm saying my name should give me my name at position O, and should give me, okay, no, not O, I. Okay, I think that's okay. No, no, no. I'm referencing I. So add my name I, and it should give me the value that is there. So it's now be my name at position I think just follow up. Let's see by the result we'll know what has happened here. So this is I for this one here. So it will be when I is what, 0, then it will move when I is what, 1, and it will be my name 0. So it will track my name 0 at this point, and to give us what, the value here, that is my name 0. Then to track my name 1, and what, track the value at that point, and then it will give us the value there by doing this second operand, this one, my name I. It will track it up to 50, and then it will stop when it gets to the last one. So I will now say I plus plus. So if I run this guy, okay, now this, okay, I'm printing characters, so it is giving me, look at, so let me, I'm using %d, I have to use %c because I'm printing the characters. So if you look at what is happening here, okay, my name at percent,
Should be %d for I. That will be inside my name.
yes, yes, for the 0, thank you. Yeah, so look at it, my percent at 0, we have this value I. Now look at 7, and all other things that are here are junk character, are junks, because it got to 50. So this is like, just like, how can we output values in an array? And this is just how we can do it. So if I want to actually, if I want to get the end value, this, if I want to reference this end string for the array, I'll have to what, say yi is less than or equal to this null character. So this null character means once it gets to this guy, it should end the string. So I can do that by saying I less than or equal to the null pointer is. So it will definitely what, stop at 6. It won't print 7 itself. So if I run this now, okay, yi is less than or equal to null, printed only something is wrong somewhere. Okay, okay. Honestly, I think something is wrong. Probably I'm missing something here, but it should actually print all the values and then stop at the null. Let me see. Let me disable this null and then print just from 0 to 6. So let's see what's going to be the output. Okay, stopping at the first value. So reference this current normal position. I. Okay. Okay, guys, I think we just get the idea of how to output the values in an array, and I will try to look why that one is not working. I think I missed up something. I will check out. Well. We've been able to establish a lot of things here, so much. But at least it's not that much. It's just to understand the key points. Pointers hold the address of a variable, and they can get the address, the value in that address by doing what we call pointer dereferencing, where you actually reference the pointer with the asterisk symbol. And when you do that, you can get the value at that address. So why do we use pointer? What's the purpose of pointer? It's for two things. Number one is called pointer, the ability to do pass by referencing, and then the second one is for memory and dynamic memory allocation. So why do we use pointer? For doing what we call pass by reference or pass by pointer to functions. I mean in functions, whereby you can pass pointer to functions and then you can use it to manipulate many variables. And then we have another one called dynamic memory allocation, where you can actually create space. You can allocate space for variables in the memory during runtime. Probably you want to create a variable and you don't know amount of space it is going to occupy. You can actually dynamically create space for it as it is executing or as the program is executing. This pass by reference is where you have a pointer, let's say pointer, you have a function, let's say void sum, and you can pass pointer to it. Okay, so int pointer A, int pointer B, and or let's say a function that swap two numbers. So I call it swap. So void swap, and you have two pointers A and pointers B. And inside this function, what is it going to do? You created a variable called temp, and you are saying that you are assigning temp to the actual value of whatever variable you pass in here, and you are saying let that. I'm not doing something like I'm doing the swap algorithm now. We are trying to say store asterisk A into temp and then store asterisk B into A. No. I'm doing swap. I say temp equals B. Okay, asterisk B. That is swap pattern. This will store inside here, and for B, I'm storing B, okay, inside temp, and I am storing temp inside A. Did I do this swap? But I'm storing A into temp. Okay, it should be A equals. Okay, so what did I do here? I store whatever value of A inside temp, and then I am now assigning that value of A, which has been stored inside temp. I'm assigning that temp value to B, and then, okay, I think it's B I have to call here. So I'm now assigning that value to A. So let's say A, if this is just a swap algorithm, if we say A is initial value of A is 5. So stores 5 inside temp, then stores temp, which is 5, inside B. Okay. And then I think I have mixed up the swap algorithm. Okay, store temp inside A, and this is where we missed it.
So is
We
it
have
A that has 5 or temp that has 5? Because I think A is a pointer, and we're assigning that to
we are
temp.
assigning, yes, A is a pointer, and we are storing the value of A inside temp. Okay, that is, let's whatever value of A, that pointer value should be stored inside the temp. Okay, it's temporary because we want to swap them. We want to swap A and B together. So we have to have a third party that will hold the value and then exchange it within among the variables. So I'm storing A inside temp, and then I'm now storing B inside A. Okay. Then the next thing that I'm going to do is to store the value of temp inside B. What do we do here? If A is 5, A will be inside temp and temp will be holding 5 too. So if B, so let's say B is what? B is 6. Okay, so we are now storing B, that is 6, inside A. Okay, so A is now what? 6, right? And then we are now what at this point storing temp, which is 5, inside B. So at the long run, we should have, so what we should we have at the end? We should have we are going to have, from the first stop, A was 5. So at the point we will not be having that what A will come equal 6, and then B will become 5. Look at what we have here. A was initially 5, so it was stored inside temp. Okay, so then B is 6. We are now storing B, that's 6 inside A. So A becomes 6 already, isn't it? So A becomes 6 already from the second, from 41. Then we are now storing temp inside B, and then B becomes 5. You know, this temp is coming from up here because A, which was 5, was stored inside temp. So now temp is 5 and is being stored inside B. So A will become 6 and B will become 5. I don't know if you get the logic there. So this is ability for us to, did you get it?
Yeah, it's clear. It's clear.
Okay, I think probably who left? That's Sheriff. Okay. So what happened here is that we can actually pass pointers to functions. Now you could have been like, why do we need to pass pointers to function? If you don't, if we think that, okay, if we say this variable is holding, this variable is A, and if we have the variable, let's say we have variables created outside, we want to swap these two variables. So we say first number is 50, and we say in second number is 30. I want to swap the two. If we think that we can pass just this value inside here and pass this value inside here, and then think that the swap will work on them like without referencing the pointer, it will just create a copy. This function will only create a copy of these two variables, such that if we print the actual value of the two again, it will still give us this initial value. It will not give us the swap. I don't know if what I'm saying is clear. The pointer we have, if we use pointers, it will actually point to the address and do the swapping at the address on the variables. But if we pass just the variable name and we just, let's say, this is a function now. This is a function that it can receive any variable. That's why we use that the parameter is A and the parameter is B, pointer A, pointer B. If we want to use these two variables inside this pointer now, we can use it. Let me take this function down. Let me take it down. Okay, oh, I didn't copy it well. So take this function down.
The mic, if we can start winding down, because most guys have left because of time.
Okay, I will round off now so we can call it a day and perhaps we'll continue tomorrow. All right, let me just finish this function. So let me declare the function here, void swap. It is to receive two int A, pointer int A, int pointer B. Okay, so we can now use the function here. So I can call swap and I can call first num. Okay, and I can call I'm calling first num. I have to call the address. So and first num and then and second num this way. So it will swap the two values. So now what has happened here is it's going to swap the value. So if I print after this function executes, if I should print, let me print first. If I do print f percent first, okay, first num, I do percent b from here, and I reference first num, and I do print f second num, and I do percent b here, second num. Then I run this function, and I what? Then come here, okay. I'll say first num swap. And I'll say this one swap so I can differentiate it. You will see how the swap actually happened. Okay, something is missing somewhere. 63. Okay, I'll close this guy. Okay, another one. Okay, I'm supposed to close this one too. Okay. Now, first is what? 50. Second is what? 30. Now the swapped happened. 30. And then second, the swapped happened 50. Now, guys, what I want you to do as assignment. Okay, let me give you this assignment. Try to take this function, this swap function, and then try to what? Just you can remove these pointers like this, from every of them. Remove the pointers and then just use the algorithm for the swapping like that without indicating the pointers. Okay, so when you run it, you are going to see that if you print the values again, you will not see, it will not work, or probably the swap. Now if I change everything, the swap will not work. Instead, it will just create a copy. I'm taking this off and I'm just working with the values. So no more pointers. So everything is just a regular variable now. And this one too from here, regular variable. And this one here. So regular variable. Even in the swap function, there is no um, ampersand or receiving or fetching of address. So if I run, you can see first num is 50, second num is still 30. Even the first num swapped is still 50, nothing happened. The second num swap, nothing happened. Why? Of if you look here, the algorithm should work because we have set temp to be A, we have assigned A to be inside temp, and we have assigned B, that is swap the number of B and the value of B, put it inside A, and then put the value of temp inside B. So why is it not working? Because it is not actually receiving the address. The address is where the value is actually stored. Instead, what is happening here is just creating the copy and nothing is even happening in the first place. And then if you go back to how it was before and you run it, the swap will work because you located the address of that value and it fetched them individually and then perform the swapping upon them. Oof, I think we'll just call it a day. I know that it is so much thing to put in, but I actually don't want to touch the function aspect of the thing today, just to get understanding of the what for how pointer works, how you can print address of values, how you can use pointer to get the address, how you can use pointer to the reference value. So if you get that basic, the rest will become easy, steady by steady, slow and steady. But guys, any other thing? We are rounding up and we are done. Is there anything to clarify or to look into?
Yeah, I know. It's okay. We can rest here. Anyway, maybe tomorrow or whenever we have time, or we'll also read. It wasn't clear about the copy that you were talking about when you said a copy. I think it needs some elaboration. But given the time and everything, and the concentration is a bit low now.
I
Okay.
agree with Ramathan. Ish.
Okay. I'll see how I will work on that. And aside that too, I'm going to send a particular link. You can just try to read pointers, and with the little knowledge we've gotten, we should be able to at least understand some things. And
Hmm.
we are going to be having projects tomorrow already. we just Let's just go with the materials. I know that they are going to start with something soft first. It's not going to be too tough. At least with this that you already having understanding about, the project will not be too complex. But as we go on, before we get to the aspect of strings with pointers and arrays, because pointers and arrays they work hand in hand, and also the ability to use pointers in functions, and there's something called the aspect of the second use case of pointers, where you can use pointers to allocate space in memory using malloc. There's something called malloc, and there's something called free. For malloc is for allocating size in memory, and free is for freeing size in memory, space in memory rather. and many things like that. So we will get that there. We get there. Let's just get the basic. Pointers
Okay.
hold address. Pointers point to address of another variable. Pointers can get the address of another variable by dereferencing using the asterisk. Whenever you are trying to create a pointer, you must point to the same address. You must create it with the data type of the address it is pointing to, and you reference the ampersand. And uh, I think that's just some basic to hold on to, and we'll move on from that point. Okay, guys.
Okay. Thank you.
All right, guys. Um, all right. Have a good night, and that's it for tonight. Bye.
All right.
Very much, Mike. Thank you so much.
All right, June.
You'll have a
Good night.
wonderful night, Tracy.
Goodbye.